All right, so let's take a look at the what it means to divide when the numbers are very large. So there's some techniques like standard division, long division algorithm, but there are also some alternative techniques and strategies that we can use. So to keep flexible, to stay flexible, and while still following the same kind of thinking. So remember, with addition and subtraction and even multiplication, standard algorithm, well, our problem was that it was the goal was to minimize the amount of space that the algorithm takes. And the problem with that was that then the language that we used to narrate what we're doing had nothing to do with the mathematics that the students learned before. So what we want to do really is to try to come up with some middle ground where kids can figure things out, that it's quite efficient, but that the language is connected to what they already know, that it's a simplification of what they know, not a completely different trick. So let's take a look at what happens if we have to divide 5,170 by 6. Well, if we had to divide, let's say, 42 by 6, kids could theoretically say, well, I can see how many groups of 6 are there in 42, right? I could say that. And they could actually go and they could say, well, I'm going to take one of the groups out, okay, and get 36. And I'm going to take another group out and I get 30. And then I'm going to take another group out, I get 24. And then I'm going to take another group out and I get 18. Oh, and then I know that that's 3 groups. Okay, so they're going to repeatedly count down, and then eventually they're going to add these up because these are what their groups, the groups that they've taken out. So 1, 2, 3, 4, so 7 groups in total. So visually, this would look like this. Let's say this is our circle of 42. They take one group of 6 out, that's 1, and another group of 6 out, that's 1, and another group of 6 out, that's 1. So now they have, when they take this, the first 6 out, they have 36 left. Then this 6 out, that's 30 left, and 24 left. And another group of 6, that's 18 left. So they know it's 18 now, and that's a group of 3 groups of 6. So this is really what they're doing. They're biting off chunks that they know are groups of 6. They're pulling out some groups of 6 until they get to a place where they know how many groups of 6 there are. So how do we transfer this to much larger numbers? Well, if we repeatedly subtract 6 and we go with 5,170 and subtract 6, one group, 5,164. Subtract 6, one group, 5,158. This will take forever, and kids realize that. So this is not a viable algorithm or strategy for large numbers. However, the kids know their multiplication facts or fact families. So they might realize, one child might realize that 8 times 6 is 48. Wow. So that means that 800 groups of 6 is 4,800. So I could pull out 4,800 here. Right, 4,800 here, and I know that that's 800 groups of 6. Let me move this down a little bit to make myself room. So I know that that's 800 groups of 6, right? 4,800 is 800 groups of 6. So I took a big chunk of it. So I took 4,800, almost all of it, 4,800, and that is 800 groups of 6. Okay, so I'm left with 370, right? 370. Now, how could I do this? Well, I could look at, let's see, maybe the kid remembers. That's 5 times 6 is 300. So 50 is 30, pardon me, stepping one step ahead. For 50 times 6 is 300. So they could say, oh yeah, I can pull out a 300, and that's going to be 50 groups of 6. That's 50 groups. Okay, and then we have 70 left. And at this point, the child could say, well, I know that 11 groups of 6 is 66. So I can have 11 groups of 6 that I pull out. So this is 66, that's 11 groups. And then there are 4 left over. So now this is how many groups of 6 I ended up pulling out of this whole total. So it's going to be 861. Right? So you see the strategy is the same. And in fact, the strategy is very similar to the standard algorithm, the long division. But the long division requires you to find the largest number, the absolute largest number, and to divide out. And it doesn't explain that we're still looking for groups of 6. What this does is it allows the flexibility for the student, especially in a situation like this, to say, oh, well, I don't know what the largest number is, but I know a pretty darn large number, 300, right? And I can pull that out, and I know those are groups of 6. So it gives the student that flexibility to do what they know they are able to do, even though that might not be the fastest way to get it done. So let's take a look at this question then. Notice that the student here is looking at 3,475 divided by 8. They recognize that 400 groups of 8 is 3,200. So they're able to identify that. Then their next step, they have 275 left to separate out into groups of 8. So they remember that 30 times 8 is 240. Okay, so that's the 30 groups. And then what they're left with is their 35. They had 275, and they grouped 240 of that into 6s. They have 35 into 8s, pardon me. So they have 35, and now they know the 4 groups of 8 is 32. So there's the 32, and that's 4 groups of 8. And we have a remainder of 3. So it's a very similar strategy to what we had done with the previous example. Now what I'd like you to do is think about how that can be rewritten in this format. Right? And finally, I would like you to take a look at 8,321 divided by 6 and see if you can figure out this scaffolded method and how that would differ from your long division, regular long division.